In this lesson, we're going to look at exponents that are fraction powers. Anytime we have a fraction as an exponent, we have to deal with it a little bit differently. So let's go to some problems and let's take a look at the rules that are involved. Here's a simple one. If we have 16 to the 1/2 power, what does it mean? Well, first of all, we have to look at the fraction itself and kind of analyze it. We want to look at the 1 on top to begin with. If we look at 1 on top, that just means 16 to the 1st power, just like we normally understand it. So the 1 on top would mean this. But the 2 on the bottom is the one we have to take special care to look at. The 2 on the bottom is a root. In fact, we can rewrite this as something we call roots and powers. So we rewrite this by saying this is 16 to the 1st power, but we take the square root of it. Now we don't have to write the 2 right here since it's a square root. If it were any other root, we would write it. So we could just rewrite 16 to the 1/2 power as the square root of 16, and it would now be in root and power form. But also to understand that it doesn't really matter which order we write these in. We could also say this is the square root of 16, and that's all raised to the 1st power, which of course means nothing in this case, but you can raise the power first and then take the square root, or you could take the root and then raise it to the power. Let's take a look at another problem here. So what would 16 to the 3/4 power be? Well, using what we just talked about, order doesn't so much matter. I know how to take the 4th root of 16, so I'm going to write it as the 4th root of 16 from the bottom part, and then the 3's on top, all raised to the 3rd power. And I'm going to see if I can simplify that. The 4th root of 16 is what number do you multiply by itself 4 times to get 16? That, of course, is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 4th root of 16 is 2. It's still raised to the 3rd power. And so 2 times 2 times 2 is 8. So 16 to the 3/4 power is equal to 8 when we completely simplify it. This one we could work out to an actual numerical answer. What if that had been a negative 3/4 power? Well, there isn't a whole lot different here, except that negative exponents, from our rules of exponents, say you move the 16 to the 3/4 power to the bottom of the fraction, to its denominator, and make it a positive power. So now it will look very much like what we just did. We have 1 over the 4th root of 16, and that part is raised to the 3rd power. So we just found out in the previous screen that the 4th root of 16 raised to the 3rd power is 8, so this answer would be 1 over 8. So the negative just moves our 8 from the numerator of a fraction to the denominator of a fraction. Here's one that's a little more complex, but we can still apply rules of exponents even though those exponents happen to be fractions, as they are in this case. Now don't get confused. 48 and 12 are coefficients. We don't apply rules of exponents to coefficients. We simply divide. 48 divided by 12, that equals 4. And we just subtract exponents when we divide like bases, so we have an x here and an x here. That's the same base. So 3 halves, or 13 halves rather, minus 9 halves is 4 halves. Let's leave that for now. And then we have a common base of y here. So 5 halves minus 3 halves is 2 halves. And I'm going to finish simplifying that. That's simply going to be 4. 4 divided by 2 is 2, x squared. And y, 2 over 2 is 1, so we just leave it y to the 1st. We don't even have to write the 1. So our final answer here is 4x squared y. And that's pretty much all there is to fractions. You can rewrite any fractional power as a root and power, regardless of how complex it gets. If we wanted to write a fractional power out of 7 to the 5/8, even though that might be a bit difficult to solve without a calculator, we certainly could do that. We could either write that as the 8th root of 7 to the 5th with the 5 underneath the square root, or as we said before, we could write it as the 8th root of 7 and raise that whole thing to the 5th power. It works either way.